let us study about the next sequence container, that is Deque, right. So, Deque stands for double ended queues, where insertion and deletion can happen in both the ends, right. So, with the feature of expansion and contraction on both the ends, right. They are similar to vectors, but are more efficient in case of inserting deleting elements. Okay. But in vectors, memory allocation is continuous, whereas in Deque it may or may not be continuous. Okay. So, that is what it is, basically implementation of data structure double ended queue, right. So, a queue data structure allows insertion only at one end and deletion from the other end. This is like queue in real life. Double ended queues are special types of queues where inserting deleting happen at both the ends. Okay. So, that is why for Deque, for this Deque, we have push and pop operations both front and back. Okay. We have push and pop operations both front and back. So, how to define it? If you want to define a Deque, the syntax is Deque, okay, the data type int and a variable name E1, something like this. You can give variable name E1 like this. Okay. So, instead of learning those syntaxes small, let us see one example here. With this example program, we will try to understand how this Deque works. See here, Deque int gquiz. So, I am having one variable here gquiz. Okay. So, how to declare a Deque, double ended queue, Deque of int and the variable name q1, something like this. Now, since it is double ended queue, you can insert and delete at both the ends. See that variable gquiz dot push back, push underscore front, push underscore back, push underscore front. So, we have 4 functions here. One is push underscore front, next one is push underscore back. Same way we are having pop underscore front and pop underscore back. Okay. So, since it is double ended queue, I can do all those 4 operations, right. So, I have pop underscore front and pop underscore back. These 4 functions we have, right. So, these are about the double ended queue. You can insert and delete at both the ends. See, in this example what is happening? Push back. So, 10 is inserted in the queue, then push front. So, 20 comes here, then push back 30 comes here, then push front. So, 15 comes here. Okay. So, show that Deque. So, this is a function we have written. Anyhow, we are yet to study the iterators. So, this is based on iterator. You are creating an iterator for a double ended queue and the variable name is it. So, it.g.begin, it.g.end plus plus. You can print that star it means it will give the values. We will study iterators anyhow. So, this function is used to get those values. So, this will print, that is this output will be 15, 20, 10 and 30. Next function in this double ended queue is size. Size will tell you how many elements are there, that is 4. Okay. Max size also same 4. So, there are 2 more functions, size and max underscore size. Next, gquiz dot at function. So, same thing, at function is also applicable here in double ended queue. At of 2 means what is the element at index 2, that is 10. Next, gquiz dot front, which is the frontmost element, 15 is the output. Gquiz dot back, which is the last element, 30. So, these are few functions, okay, size, max size, at, front, back, push front. Next, gquiz dot pop front. So, front means this 15 will get deleted, pop front means 15 gets deleted. Okay. So, when you write this pop front, the 15 gets deleted. When you show, the elements will be 20, 10 and 30. Same way when you call pop back, so the last element is deleted and the queue will be 20 and 10, right. So, in this single program we are having so many functions, push back and front, pop front and back, then size, at, front, back. Okay. So, these are few functions in double ended queue standard template library or a sequence containers in C++, right. So, this Deque is special because it is implementing a data structure, in queue data structure we have a version called double-ended queue that is being directly implemented, and you need not write the logic. You see, we are not writing any implementation logic here. That is what we studied, we said when we studied about containers. You need not write any implementation logic. By using functions you can do that. Same thing, if I want to implement queue in data structures, what we do there? We write the code, no, we write the enqueue logic. We have to write this logic, all those steps. We also have to write the deque logic. Okay, all those steps we have to write. But here using STL, they are having inbuilt functions, which the method, the implementation method is also given already along with the STLs. That is why STLs are very popular in C++. So this program demonstrates about different kinds of functions what we have in this Deque STL library in C++.